If you're losing marks on dynamics questions, there's a good chance the problem isn't your math. It's your free body diagram. Today, I'm going to show you 4 common free body diagram mistakes that I see over and over again. See how many you've made before. Let's get started. Take a look at this free body diagram. Can you spot the mistake? This diagram includes something called a motion force. But here's the problem. Motion force isn't actually a force. So the first mistake I want to talk about is drawing a force that doesn't exist. Every force must come from an interaction. So whenever you draw a force, ask yourself, what's causing this force? If you can't answer that question, it probably doesn't belong on your diagram. Just because an object is moving doesn't mean there's a force in the direction of motion. Motion tells you what the object is doing. It doesn't tell you what forces are acting on it. So never draw a motion force on the diagram. Let's look at another example. Take a look at this free body diagram. Can you spot the mistake this time? Which force doesn't belong here? Or another way to think about it. Which force comes from nowhere? It's this one, the centripetal force. A lot of students see an object moving in a circle and think, oh, I should draw a centripetal force, but that's actually not a force you draw. Let's use our rule. Where does it come from? Does it come from the road? Does it come from the earth? Does it come from the engine? No, none of them. It comes from nowhere. And that's the problem. Every force on a free body diagram must come from a real physical interaction. Centripetal force isn't an extra force. It's simply the net force provided by the forces that are already there. The normal force, the gravity, friction, or a combination of them, depending on the situations. So never draw centripetal force on your free body diagram. Now let's look at another common mistake. This one is a little trickier because there are 2 objects. Can you spot the mistake this time? It's the friction force. The direction is wrong. A lot of students think friction always points opposite to the direction of motion. But that's not the rule. Friction opposes relative motion, or the tendency of relative motion between the 2 surfaces in contact. So let's think about these 2 blocks. If there were no friction, what would happen? The bottom block would move to the right, but the top block would tend to stay where it is. That means, relative to the bottom block, the top block would slide backward. So in this case, friction points to the right, which is the same direction as the system's acceleration. Here's the rule to remember. Don't ask which way is the object moving. Instead, you can imagine friction disappears for a second and then ask, which way would the surface slide? Friction points the other way. Now let's move on to mistake number 3. This time we have 2 blocks connected by a string. I've drawn 3 free body diagrams, one for block A, one for block B, and one for the entire system. Can you spot the mistake? The mistake is right here. The tension force shouldn't be included in the system diagram. Here's the key idea. For block A, the tension force is outside of the block. It acts on block A, so you should include it. The same is true for block B. The tension force is also external to block B, so it belongs to block B's free body diagram. But once you choose both blocks together as your system, things change. Now the tension acts inside the system. It pulls one block one way and the other block the opposite way. So it's an internal force, and it should not appear on the free body diagram of the entire system. So remember this. A force isn't automatically internal or external. It depends on what you've chosen as your system. Now let's look at one last example. Can you spot what's wrong with this diagram? This time, nothing extra was drawn. Instead, something is missing. It's the tension force. The rope is pulling on the blocks, so the tension force should be included. Missing a force is just as common as drawing a force that doesn't exist. So if you leave out just one force, everything that comes after it is built on an incomplete picture. Before you put your pencil down, ask yourself these 4 questions. Did I invent a force? Are all my force directions correct? Did I include any internal forces? Did I miss any forces? So here's the problem. Spotting a mistake is easy after someone points it out. But how do you catch it yourself? That's exactly what next video is about. I'll show you a simple process that I use for every free body diagram. I'll see you in the next video.